This conference will now be recorded.
Hello students, now I am going to give a demo on how to design the Chebyshev filters. The third experiment we have seen the design of Butterworth digital filters using MATLAB. Now in this program, in the fourth program, I am going to tell you about how to design the Chebyshev filters. We are going to discuss about the Chebyshev low pass, high pass, band pass and band stop, four types of filters. Now I will share you the screen and then explain how we can design this. So coming to the program, CLC close all clear all. So these are all the commands for clearing the workspace. CLC is for clearing the command window. Close all and clear all commands are clearing the workspace and then the previous history, whatever the commands that are there. Same thing here also, as we have seen in the Butterworth filter, the same logic works out here also. RP is equal to input of enter the passband ripple. RS is equal to input of enter the stopband ripple. Omega P is equal to input of enter the passband frequency. Omega S is equal to enter the stopband frequency. Fs is equal to input of enter the sampling frequency. After entering all these five parameters, we are going to normalize this one as usual. Omega 1 is equal to 2 times omega p by fs. Omega 2 is equal to 2 times omega fs slash fs. And we are going to return the two parameters known as order and cutoff frequency. N comma omega n is equal to cheb 1 naught of omega 1 comma omega 2 rp comma rs. So taking into account four parameters known as omega 1, omega 2, rp and rs, it is going to return the order and cutoff frequency of this filter. N is the order of the filter, omega n is the cutoff frequency. And b comma a is equal to Chebi 1 of n comma rp comma omega n. So b comma a stands for the filter coefficients as usual. So b stands for the numerator coefficients and a stands for the denominator coefficients. So it is going to return the Chebyshev type 1 filter coefficients. Chebyshev type 1 filter coefficients is going to return. So b comma a is equal to Chebi 1 of n comma rp comma omega n. So it's going to take into account n comma rp, that is the passband ripple, and the cutoff frequency omega n. Then omega is equal to 0 is to 0.01 is to pi. So omega is varied from 0 to pi in steps of 0.01. So 0, how many values will be there in this? So totally there will be 314 values. 0 is 0.01, 0.02 like that up to pi, 3.14. Next, h comma om is equal to freq z of b comma a comma omega. As usual, is going to plot the frequency response in the domain. The values that are stored in b and a, they are mapped into h, and the values that are stored in omega, they are mapped into om variable. Then after calculating this h, which is complex, h will be complex. Frequency response is generally complex, so it's in the form of a plus jb. Every point will have its own magnitude and phase. Okay, every point will have a plus jb root of a square plus b square tan inverse of b by 2. To do that, we have taken the 20 log 10 abs of h. For every point, you need to calculate the magnitude and phase. An is equal to angle of h. The angle of h command returns the phase. The plot of 211. So we have divided the entire screen into two rows, one column first position, 2 comma 1 comma 1. So two rows, one column first position. Then plot of om slash pi comma an. Plot is the difference between plot and stem commands is plot is used for continuous time signals while stem is used for discrete time signals. So om slash pi, you already normalized the filters. So om slash pi comma m. So it's going to plot the magnitude response. Then y label of gain in dB, x label of normalized frequency. The second position is going to plot the phase response, subplot of 212. So 2 rows, 1 column, second position, subplot of 212, plot of OM slash by comma AN. So then you are going to use X label and Y label. So totally, this is for the design of Chebyshev Cheb 1 odd, means that it is Chebyshev type 1 order of the cutoff frequency of the filter. Chebi 1, meaning that it is going to return the Chebyshev type 1 filter coefficient. So what are the commands that are important here? Cheb 1 odd, Chebi 1, freak jet, ABS, angle. Of course, subplot and plot commands. The difference between subplot and plot commands is subplot is not going to plot, but plot is going to plot the continuous time signal, because the main we are not going to use the stem command here, because DTFT is continuous, the spectrum is continuous in nature, whereas DFT spectrum is discrete in nature. That's why we are not going to use the stem command here. We are going to use the plot commands. Okay, so this is about the program, logic of the program. Now let us enter the parameters in the command window, and then let us generate the output for the low pass filter. We are going to generate the magnitude response and the phase response for this particular low pass filter. So run this program. So it is asking enter the passband ripple. So enter 0.5, then 50, then 1500, next 2500, next 9000. So enter these parameters in the command window. Five parameters have to be entered as usual, as you have seen in the Chebyshev filters, these Butterworth filters. Enter all these commands and then press enter. Now you will get the output in the figure window. I will share you now. I will show you the. I will share the screen and then show the output. So this is the output of the Chebyshev type 1 low pass filter. It's going to pass only the low frequency components and reject the high frequency components. And the phase response is non-linear in nature. For the IR filters, generally the phase response is non-linear in nature. X-axis you have the units 0, 0.1, 0.2, 0.3, etc. up to 1. Normalized units. Y-axis you have 0, minus 100, minus 200, minus 300, minus 400, etc. Y-axis same 0, 0.1, 0.2 up to this, sorry, phase response, same thing is there 0, 0.1, 0.2, etc. up to 1. Y-axis you have the phase in radians 0 to 4, minus 2, minus 4, etc. So all these things are will be plotted like this. So totally you'll have in the screen you have the screen is divided into two rows, one column, first position and second position. 211, 212. 211 means two rows, one column, first position. What is plotted? Magnitude response is plotted. Next one is two rows, one column, second position. Phase response is plotted. Like this. Like this, you are going to design the Chebyshev type 1 filters and generate the plot. Now let us go for designing the Chebyshev type 1 high pass filter next. So this is Chebyshev type 1 high pass filter, program for Chebyshev 1 high pass filter. So as usual you are using CLC close off here all. The program is same, there is no change in the program. Only one command change is there. Entering the input parameters, normalizing the frequencies, calculating the order and cutoff frequency, filter coefficient, frequency response in Z domain. All these are same. Only one command difference is there, that is Chebi1 of n comma rp comma omega n comma high b comma a. You can see in the line here b comma a is equal to Chebi1 of n comma rp comma omega n comma high. You are going to use the Chebyshev type 1 high pass filter. That is only the difference here. Remaining things are same. That's only the difference. Now let us run this program and then generate the output. Same parameters are entered in the command window 0.5, 50, 1500. You can enter different values also. Now I will show you the plot which is generated after entering these parameters. Figure window. So this is a figure window that is generated after this particular entering the commands, entering these parameters. So you are going to see a high pass filter which is passing only the high frequency components and rejecting the low frequency components. So this is the response for a Chebyshev 1 HPF high pass filter. X-axis you have normalized frequency, magnitude response and phase response. Once again, entire screen is divided into magnitude response and phase response. Magnitude response we have normalized frequency gain in dB. Phase response we have normalized frequency phase in radians, etc. So the units are 0, 0.1, 0.2 normalized frequency up to 1. Y-axis you have 0, minus 50, minus 100, minus 150, varying steps of 50 dB. Same thing. Phase response you have normalized frequency versus phase in radians. The phase response of IR filters are non-linear in nature. Right. Now let us go for the design of uh, Chebyshev type 1 band pass filter. This is for the program for designing Chebyshev type 1 band pass filter. So the same programs will work out here also. There is a small change here. We are using there in low pass and high pass we are using n comma omega n. But here you are using n is equal to Cheb 1 odd of omega 1 omega 2 rp comma rs. N is equal to, so n returns the order as usual. Chebyshev type filter on order. Omega n is varied in the band of omega 1 omega 2. Omega n is a cutoff frequency which lies in the band of omega 1 omega 2. What are omega 1 omega 2? Omega and omega 2 are normalized low pass filter, this pass band frequency and stop band frequency. Then b comma a is equal to Chebi 1 of n comma rp comma omega n comma band pass. So you are going to use here n rp omega n band pass. You are going to use a Chebyshev type 1 band pass filter and generate the filter coefficient. B and A stands for the band pass Chebyshev type 1 band pass filter coefficient. As usual, you are plotting the frequency response, magnitude response, and phase response. These are all these commands are same. 20 log 10 ABS of H, angle of H, subplot up to 1 1. Subplot up to 1 1, first position what is plotted, magnitude response is plotted. Subplot up to 1 2, phase response is plotted. So remember that n is separately used, omega n is separately used here, and b comma a is equal to the filter coefficient, generating the filter coefficient. Now let us enter the parameters, run this program and enter the parameters as usual. Now after entering the parameters in the command window, so you have to enter the command window what I showed you for low pass filter, the same way you have to enter. So this is a figure showing the Chebyshev type 1 band pass filter, which is going to pass only certain band of frequencies and going to reject the other band. So the phase response of Chebyshev type 1 is non-linear in nature. You can see that the magnitude response and phase response. X-axis you have Chebyshev type 1 filters. Normalized frequency for x-axis, normalized frequency in terms of 0 and 1. Y-axis you have this one. So phase response is the same thing. So first position magnitude response is plotted, second position phase response is plotted using the subplot command. Right. The final one is we need to design the Chebyshev type 1 high pass filter. Now I will show the program for Chebyshev type 1 high pass filter. Sorry, Chebyshev type 1 band stop filter. Chebyshev type 1 band stop filter. We have designed low pass, high pass, and band pass. Now we have designed Chebyshev type 1 band stop filter. So the program is same here. RPRS, omega P, omega S, and Fs are the input parameters. The only difference is, as you have seen in the band pass filters, n is equal to F1 of omega 1 comma omega 2 comma RP comma RS. We are going to generate the order using this particular command. Then omega n is the cutoff frequency, which is rise in the range omega 1 and omega 2. B comma A are the filter coefficients for the Chebyshev type 1 band stop filter. So the important command here is n comma RP comma omega n comma stop. Same thing here also, you are going to generate the magnitude response and phase response and then plotting the magnitude response and phase response. We are going to use subplot of 211 and subplot of 212, plot of and plot commands. Now let us run this program and enter the parameters. So 0.5, 45, 1500, 2500, 9000. After entering all these parameters, output is generated. I will show you the output now. This is a figure showing the Chebyshev type 1 band stop filter. So it is going to reject certain band of frequencies and pass all the frequencies. It is going to reject the certain band what you have given in the program. So we are going to reject the band whatever you have given in the program and then pass all the other frequency components. So the below is the phase response for this particular thing. Same in the first position 211, the plot of 211 means first magnitude response is plotted. Second position 212, the plot of 212 phase response is plotted. So this is the design for the Chebyshev type 1 band stop filter. So in this program we have designed the Chebyshev type 1 low pass, high pass, band pass and band stop filters. We have generated the magnitude and phase responses for each case for low pass filter, for high pass filter, for band pass filter and band stop filter. In the next video demonstration, we will be discussing about the FIR filters. Fifth program is FIR filter. Thank you.